if you're interested in receiving a white paper on the same topic or receiving the slide deck, you can email Chris Rudder from Brady Corporation by clicking on the purple widget at the bottom. When you hover over it, it says Email Brady Corporation. I'd like now to introduce to you Chris Rudder.
Thank you, Mark. And on behalf of Brady Corporation, I'd also like to welcome everybody to the webcast. My name is Chris Rudder. I'm a marketing manager here at Brady, focusing on chemical, oil, and gas. And I've had the pleasure of knowing our presenter today, Robert or Bob Williamson, for many years. Bob's the president of Strategic Work Systems, one of the most highly regarded maintenance and reliability consultants in the country. And in his spare time, Bob's also an educator and an author. He serves as an instructor at the University of Dayton's Center for Competitive Change, and also instructs at the Maintenance and Reliability Center housed in the University of Tennessee, Knoxville. And we're really glad to have Bob with us on the webcast today, mainly because he's written the Bible on using visuals to improve equipment performance and reliability. He's also spoken on that topic at numerous industry conferences and seminars. For those who are interested, we'll provide more information on Bob's book at the end of the webcast. But for now, without further ado, let me just say, Bob, thank you very much for coming, and take it away.
Well, Chris, thank you. Thank you, Mark, for kicking it off. And as we look at the visuals here, I want to have a reminder for people that when we talk about equipment visuals, think beyond painted lines on the floor, think beyond placards hanging from the ceiling. This is equipment-specific, task-specific visuals that will lead to improved safety, improved environmental, and improved reliability performance of your equipment. Most of what I'm going through today are tried and true, workplace hardened examples. We've selected just a few of them to share today, but the power of these things just cannot be overstated. We've got a lot of challenges in the petrochemical, oil and gas industry, the outdoor environment, and we're getting into an era where some of the challenges go beyond just the environmental issues and weather issues, and it's the aging workforce issue. As the baby boom generation ages out, not necessarily retiring, but ages out, we're unable to do certain things, leading to skill shortage. We've got two generations behind the baby boom generation, that smaller generations, not as prepared in maintenance, reliability, manufacturing, maintenance kind of skills. We've also got lots of new technologies out there that provides a very steep learning curve for employees, not only the new employees, but the existing workforce. Challenges with training effectiveness. The old traditional approaches to training, classroom training, are not as effective as task-specific training, equipment-specific training, procedure-specific training, and we'll get into some of that. But also challenge is error-free human performance. Most of the challenges, and when I say most, I'm talking about 99.99% of the errors and the problems that we have and reliability issues and incidents are related to people. People making mistakes, people not being trained, people doing things that they shouldn't be doing, which also has caused more stringent regulatory requirements. And then if any of you guys are in lean manufacturing, lean environments, lean enterprise environments, Six Sigma, you're in a continuous improvement cycle in everything we do, not just visuals and not just equipment stuff. And visuals play right along with that. Of course, the harsh environment, onshore, offshore issues, outdoor issues, the visuals that we're going to show you are not your typical office label maker kind of things. These are industrial hardened examples. So moving right along, we want to talk about some of the basic techniques to make your equipment more reliable. And we call these labeling, color coding, marking, tagging things. That whole family of those tools are called equipment visuals. And they're designed to be low cost, easy to apply, customizable to your site, rather than buy off the shelf pre-printed and pre-shaped. And just some ideas here about visuals. They lead to improved efficiency, improved effectiveness. Things get done within the right times and the right things get done. The equipment visuals served as reminders. It's sort of like that little sticker that's right next to emergency, an e-stop. You know that's an e-stop because of the label. Well, it goes beyond that. It goes to the critical things that people are asked to do. Let's put some reminders, early warning signs. Communicates process settings and procedures. Again, it serves as a reminder. Here's what the process setting is. Makes equipment easier to inspect. And this is one of the things that I've learned to appreciate teaching maintenance and reliability techniques for going on 4 decades. We're trying to find ways to make equipment easier to inspect, easier to operate, easier to maintain. But these visuals also lead to reducing equipment-specific training time because those visual cues are on the equipment where you need them. They serve as reminders of what you learned in training. The key points, the critical points of decision-making that you taught in training. Yes, people tend to memorize those things or put cheat sheets in their pockets for the first little while on the job. But the equipment visuals, we put them on the equipment. And, of course, these visuals help reduce problem-solving time. Okay, moving right along. We've divided this presentation into 10 groupings or 10 examples of visuals. The gauge marking, the analog gauges, equipment lube, replacement parts identification, just equipment component IDs, fluid levels, fluid types and levels, checklists and procedures, condition monitoring visuals, positioning, pipe and valve, and then lockout tagout are the 10 areas we're going to breeze through today in this web seminar. Starting out with the gauges, the typical analog gauge, the one right in the middle that has a question mark on it, is quite often what we see in plants and facilities. You've got to know what it's telling you. You've got to know what the right reading is. But the visuals, if you look around the periphery there, the one in the upper right-hand corner, it's got the little green band. That's obviously the acceptable range, the allowable range. The label says it's pump number 1, and you can actually label, what the PSI is, but you show it in the green band. The Magnehelic gauge, the differential pressure gauge down 6 o'clock position, you can see the green range on that piece of tape that's on there that shows the proper or the normal operating range, and it's currently in the red zone, which means it needs some action. Like if this is the filtration system, that indicates that either the system is off or the filters have fallen out. So you still have to know something about the equipment that these visuals are applying to. And then the other one on here, just labeling, what is the gauge telling me? What is it measuring? What should I learn by looking at this gauge? So another example, we move along to the, before we finish the gauge piece, we'll talk about the type of labelers and printers you have, and we've got a poll question. And we'd like to have you respond to the poll question. Chris, did you want to say something about this? Okay, moving right along. The label makers are plentiful in business and industry, and my experience in lots of plants is many places try to use the office type labeler, the little laminated labelers, and those things don't tend to hold up well. There are more permanent, more robust labels for indoor-outdoor use, and we're trying to poll the audience, those of you out there, what kind of facility your labelers your facility has. Like labelers, label printers, print on vinyl type labels, engraving machines or stamping machines that produce either the metallic or the fibrous or the plastic engraved label that are either glued or riveted, screwed to the machine, or if you have both. And then, of course, if you have none of those, again, keep in mind that the type of labelers and printers and engravers would be the industrial hardened ones rather than the kind that you use to label office drawers and bins. So if you answer the poll question, we'll give the results at the end of the session. We got one more poll question as we go through. So the questions are, do you have label printers, engraving or stamping machines, both of them, or none of those in your plants? So respond to that and click submit. As we talked about gauge labels, a couple different techniques. One are the gauge labels where you actually, it's a translucent, transparent type of sheets available in the red, yellow, or green color. The green, again, intuitively tells you it's acceptable, it's the allowable range. And you can see two examples on your screen. The one to the center left, it says process X temperature, and the set point is 74 degrees. And notice how the green label is actually pointing to that 74 degrees Fahrenheit. But you can also have the same system that says process X temperature, set point is 74 degrees, but there's a range, an allowable range. So in the plants where I see this, it says, yeah, we set it at 74, but during its normal operation, it can vary. So that green range shows the variance. One of the Brady tools that's available, the Markware software, you can actually customize in the color label maker and make the entire label the red-green band, red-green-yellow band. You can put text on there that shows what the process is and what we're measuring, and it prints out a label, cuts the circle, and you set it in the center of the gauge, similar to a couple of them we showed in the earlier slides. But one of the points to keep in mind about these is the labels still require routine PMs. Most of this label material we found lasts a year or longer outside, but occasionally it does get damaged or scuffed or whatever. So as part of your PM program, you need to maintain these equipment visuals. And we'll chat about that as we move forward too. So we've finished with gauges, the analog gauges, now lubrication. Lubricants, so many rotating equipment pieces are damaged by improper lube, wrong lube, too much lube, not enough lube, contaminated lube. So the labels help at least provide a visual that says, here's the lubrication type, the interval, how often, the amount, and the method. Several examples here. There's a lube point label. The label in the center of the screen says 1 pump weekly, and it's a lube point number 8 in the sequence. And it's green, and you notice that the grease gun over there has the green label on it too. So there's a color code matching that you can do with the labeling in the grease gun or the containers for the fluids. Center at the bottom, lube point number 15, and there's 4 red grease fitting caps in there to protect the Zerk fittings. So those grease caps do two things. One, protects the little check ball in there from getting contaminated or jammed or rusted open, but it also provides a color code. The label, and again, these are industrial hardened labels, the Brady labels from the label machine, tells me it's lube point 15, 4 fittings, weekly, 1 pump, with a Chevron synthetic EBP grease. The labels reinforce what's in the lubrication PMs, the lubrication route, the lubrication procedures. It's not designed to replace it. It reinforces, helps error-proof and mistake-proof. The visual in the lower right-hand corner was an interesting case example in a plant we ran into out in Nevada a number of years back, where they had lots of pump damage, motor damage, bearing damage because of over-lubrication. And we found out from just a good maintenance practice, they weren't removing the vent plug to allow the old grease to run out. So for years, about 5 years, they've been pumping grease in there without taking out that vent plug. So the grease was actually filling up into the windings of the motor, swelling, expanding, and causing motor problems, and also going down into the pump itself. So the label merely says, grease vent plug. And it talks about removing remove while you're greasing it. Allow the old grease to run out. It finishes purging, and then you put the plug back in and clean up the mess. But it goes back to the principle that bearings like this need more air than grease to run properly. And machines typically don't eat grease. It's got to go someplace. So that's the purpose of the vent plug. So we found those custom labels to be very helpful. And these are make on your site kinds of labels. As we move into the third component, which are the replacement parts, what I've found out working with lots of maintenance mechanics and people out in the plants to identify the replacement parts for filters, for chains, for belts, we put the label on the equipment that tells what the replacement filter is. In fact, you can see in the yellow one up at the 1 o'clock position, it's got the part number and the actual storage location. Makes it easier to find. You don't have to look things up so much. The one down around the 4 o'clock position, filter 275P, it gives the OEM number, plus it's got the stock number. This was a plant up in Ohio, and we found a stack of these brand new filters in a corner damaged by the fork trucks and dust. So the team decided we better put a price tag on these so people realize that these filters cost us $128 a piece. The bottom center is basically behind the cabinet fans in motor control centers, in PLC cabinets. Behind that grate is the filter. Well, this label on the outside tells what the filter size is, so you can pre-cut it and have it available. And then one over in the expanded metal mesh over the guard. This team cut the side of the guard off, put the mesh in there, painted it flat black so you can see through it. And the labels on there provide the direction of rotation and the replacement belt numbers. Again, the advantage here with this visual is you can see through the guard and inspect it with a strobe tachometer while it's running. You can literally inspect the underside, top side of the belts, the shivs, the keyways, and the bolts holding it all together while it's running. So you can go from a downtime PM to a running PM with that type of modification. Moving right along, still on replacement parts, you get into the parts room or the part storage areas, labeling opportunities, the locations, the rack, shelves, and bins, the part numbers. In fact, you can see on the far right, the slide shows an actual profile or a shadow of the screw that's in there, shows it's the Phillips head screw, and it actually states what it is in there. The other example is this photograph. And again, one of the Brady label makers it gives you the ability to put the photograph in there of the actual part, plus the name and the size and the spec of it, so people can see it. And we're a very visual society, visually oriented now, probably more so than we were 2 generations ago. So not only does the wording help, but the picture or the image of the part helps people figure things out too. And of course, you can see the other pictures with the shelves and bins labeled. This is an excellent example of a very creative use of label. We found this one in a pharmaceutical plant down in Florida. And we've been labeling the outside of the equipment with key points, lubrication points, replacement part numbers, and went back to the plant, and the electrician had labeled inside the cabinet to show the part locations, what the parts were, but he actually put the graphic images in there too. So one of the challenges they have in that plant are people working on the equipment that haven't seen it before. Yes, they're electronics. Yes, they're electrical people. But he wanted to make sure that people understand the equipment from his perspective. So he took his sense of ownership for the equipment, put it inside the cabinet by way of the labels that you see there in yellow. Very creative use of pictures on the labels. Okay, equipment and component identification. One of the worst work orders to get is a work order that says machine's broke, and you don't know, well, what machine really is it. So we found out that if we can name the equipment, the far right picture says it's a Stamco machine. It's a number 4 bridle, and the equipment number is on there. That's the same number that's in the computerized maintenance management system. That's the same number that you want to have on a work order. That's the same number used to track equipment history. But for the longest time, people put in a work order for the Stamco. Well, there's many pieces of equipment in that plant made by Stamco. So which one was it? Well, the mechanics, they kind of knew what it was. So we wanted to create a habit where people use the proper name to build that equipment history. You can also see examples where we've got in the middle here, the air compressor number, the switch 237, the main disconnect for it, and then some pump operating parameters for the pump P115A. So again, it's getting the information that people who've worked in a plant for a long time may already know. But let's get it out there. And not that we're forgetful, not that we're stupid, not that we're unable to do things, but let's try to provide these visual cues, these hints and tips to make sure that we don't make mistakes. And we also build a proper data collection system in the work orders. And moving along to some other equipment visuals, you can see different expansion tank 1, expansion tank 2, off to the right, labeling the electrical controls for the different pumps, the pump numbers, labeling, of course, your safety with your pinch points and so on, the permit requirements, standard or customized labels on the equipment, are some excellent examples. And many people, many plants are used to the different hazard and danger symbols, but let's start naming the equipment so we all call it the same name. It's also useful if you've got a changing or revolving workforce, new people coming in, rotating workforce because of skill shortages, maybe contractors coming in to label your equipment. Moving along, some other ones, just different sizes. You can see the lifting and rigging equipment on the board there. This was a plant we ran into in Wisconsin. Just labeling so we know what lifting mechanisms. Some are SAE threads and some are metric threads. So they were easily getting those mixed up and try to force a metric thread in the SAE hole. It causes some problems. And down the lower right corner is a shadow board. And this is a customizable shadow board. You actually make these labels to go on your boards to help organize. Typically, this would be part of a 5S or a 6S program in your workplace organization and orderliness efforts. Fluid levels. A lot of misinterpretations when the fluid levels aren't labeled like you see in the pictures. I've been in literally dozens of plants that people say, well, as long as you can see oil in there, it's okay. And the equipment manufacturer says, you know, if it gets below this level, you could have some problems. So what we do here is a couple things. The striped card in there, I call it a zebra card because it looks like a zebra. But you notice with a simple principle of physics and light, where there's a fluid there, it turns those stripes different angles and different widths. It turns that cylinder into a magnifying glass. So you can see that off to the right, mobile synthetic label there tells me type of lube. You can see the sight glass in there with a zebra card. And you can see from quite a distance away, you can see where the lines are magnified, and it's above that green line level. The other zebra card in the center has a green line printed onto the card, and that's a customized Brady label that you make to show what the level is. And they're actually stuck on the outside of the gauge. They're not in the fluid level. Makes it a lot easier to see. Again, we call those zebra cards. Other things for fluid levels is just the fluid type, the NFPA information in the global harmonized system, so we know what's in here, part of the MSDS too, what kind of chemicals and products we're working with. Those labels are also easily customizable using the label machine. Number 6, checklist. Checklists and procedures. What we're showing here are 2 examples. The one in the center of the slide, center near the bottom, is a lubrication diagram. And it shows all the lube points, the frequency, who does them, the description of them, where it's located, the type of lube, and some instructions on how to lubricate or replenish the lubricant. And it's laminated and it's posted right next to the machine. Every lube point is numbered in the diagram, but it's also numbered identified on the machine. And this lube chart or lube diagram actually mirrors what's in the lubrication procedures. So you've got a hard copy posted as well as what is in the lubrication or the PM procedures. And the other procedure checklist off to the right, customized format you make to put in the pictures of your equipment, the step-by-step procedures. Again, these act as visual cues. They're attached to the machine, laminated to the machine, or they're attached to a visual board next to the equipment area. Lots of uses of images as well as the words in a sequence and colors. As we look at visual procedures, this is a compressor, a blow molding compressor, the blue bottles for soft drinks. And the compressor manufacturer had a warranty requirement that says for the first year we need to have pressure readings, temperature readings, and so on. So we took the reading compressor log sheet from the manufacturer and modified it, and that's the diagram you see in the center part of the slide. We divided up the inspection points by what you're looking at, temperatures, pressures, and so on, amperages and hours. We put in the type of reading, what the normal range was, and then a place to write in this history sheet whether the compressor was on load or off load, and there was a light on the panel that actually told you that. And then the diagram was just the diagram out of the compressor manufacturer manual, and the hour meter and the amp meter right out of the manual, dropped into this document, and then on the actual compressor, part 2 is down near the lower center. Every inspection point on the compressor was labeled to match the diagram. And you can also see the green gauge label that shows the allowable ranges. This was important in the plant because the operators and all 3 shifts, in fact all 4 shifts, were required to take the readings. They weren't taken by maintenance people, so we had to train the operators how to take the readings, what to look for, and the visuals actually made that easier and gave us more reliable data. Condition monitoring. This gets into, what's important, what should we pay attention to, and where is it, and we want to make it visual. So a couple examples here of just roller chain. How do you know if the chain has enough slack in it? Is it too tight? What should it be? And these are obviously slower moving chains, not fast chain. The one in the lower center, the arrows show the direction of rotation, and you can see the chain slack is in the green area. That's the allowable slack. If it's in the red, that's either too slack if it's down below, or I don't know how to get up in the red above because that's over tight and the shafts will be out of position. The other diagram shows the chain slack on the top side, and you can see it's in the green. And again, these are labels that were just custom printed and attached to the machine. A couple other condition monitoring we look at. One very common thing in rotating equipment, of course, is vibration analysis, collecting your vibration data. And one of the challenges we have in vibration analysis is consistent data collection. In other words, the horizontal, vertical, and axial points, you take your readings exactly the same place. So these are some labels that were developed for these plants that shows here's the vibration test point here. It's attached to the machine. Sometimes it's just a label that says test point. Other times it has a point number, so you can track that point number in your vibration analysis software. There's an ultrasound test panel, a test point for your ultrasound probe. So again, it gives you the consistent readings to make sure that your equipment history and trending is going to be accurate. Positioning valves and switches. Again, in lots of plants, you take it for granted. Well, the valve's supposed to go this way if it's open, this way it's closed. Well, what's the normal position? And you can see valve normally open. We line the label with the valve handles. The ball valve handle in the center to the right, the valve normally open. It aligns with the handle. Of course, your on-off switching electrical panels. But the green arrows in the lower right-hand corner show these are the normal switch positions. This is where you set it for normal operations. And it's got those 4 green arrows there. So it makes, again, it's a visual cue, it's a visual reminder. And keep in mind that these equipment visuals are not designed to replace training. It's not designed to just let's label everything so people go out there and they can do things properly. It's reminders, it's visual cues. Okay, pipes and valves. We want to know what is the pipe valve, what's in it, what's the contents, what's the direction of flow. Where's it coming from? Where's it going to? Identification, like for safety valves, identification for critical valves, and then color coding for the different materials. You see some examples here. You've got the glycol to and the glycol from, chill glycol, the direction of flow, valve tags. You can see those, the wraparounds for the fire protection water. But also the structure label, it shows the different levels of the structure. Think of this as one of your cracking towers or multi-level facilities. You can see what valve and instruments are at which level, and this would be posted on the ground floor as well as each one of the levels. Makes it easier to find things in the general area, and then you go to the valve, and of course the valves and instruments are labeled too. Lockout and tag out, very, very common thing. Quite often it's overlooked, and that's where accidents happen. Labeling, not only the lockout tag out points, but you notice down in the lower part of the picture, lower left, is a lockout tag out procedure, a visual procedure. It's a Brady format. It's got the pictures, it's got the step-by-step procedures, it's got the lockout points, and it's got the sequence. And it's also got the information on a lock, tag, and try to prove out that these systems work. And one of the things to keep keep in mind here is, as we wrap this part up, is you can begin applying the visuals as your equipment is being designed and built. I actually worked with a number of equipment manufacturers where they're customizing equipment. The customer said, we have a 5S visual workplace, and we want to make sure the visuals are on the new equipment when we bring it in. So a number of manufacturers are applying these things to their equipment at customers' request to open up the guards with Lexan panels or polycarbonate panels, to label all the lube points. Again, this is a very collaborative effort to make sure that they use the same type of lube identification, point identification, numbering sequences that you do in your plant. So we're seeing that the new equipment hits the ground, it's ready to go. But you can also do it during installation, startup, and commissioning. And it's a good activity for your on-site crews to get to know the new equipment, because they can start labeling the equipment to match the rest of the equipment in your plant. Keep in mind that you want to focus on your critical information on the equipment. Don't try to over-label it. Down the list, I call it visual clutter. I've been in some plants where it's like they invested in a truckload of labels and had to use them. So just keep in mind that it's putting the critical information on the equipment where there's been a history of errors, a history of not knowing, or it's so new that you want to put the reminders, the visual cues out there so people are reminded to do the right thing. The visuals should be very specific and very purposeful. Again, it's putting information on the equipment that reminds people, here's what to do, here's what it is. Don't put visuals on there just to make it look pretty. They have to have a purpose. If they don't have a purpose, it turns into visual clutter. Keep in mind that one of the big advantages, of course, is error-proofing the operations, and it's a reminder of training. So if we've got new employees coming in or contractors coming in, and we give them some orientation and training, we want to have those visual reminders in the workplace on the equipment. Again, I'm so heavily oriented here to the people issues, because we're the biggest cause of equipment problems, of safety environmental problems. And not the equipment, it's what we do to it, what we do with equipment, or mistakes we make, or errors. Whatever you do in visuals, you're backing up information that's in a detailed work instruction or a detailed procedure. As I said before, the visuals aren't designed to replace the procedure or replace the checklist. They're visual cues, they're reminders. I've mentioned visual clutter several times. Really, you can look at your equipment and say, there's so much important stuff that people need to know, but step back and say, if we put all of this information on there, is it going to be so cluttered that people will tune it out? So be very frugal with the visuals. Make sure that it is there for a specific purpose and doesn't turn into clutter. As I said at the beginning of the presentation, if you put visuals out there, you're going to PM them. Like any part of equipment, it requires preventive maintenance. I've had some questions asked recently from people that say, well, our gauge labels don't last very long. I said, well, how long do they last? Well, it's been out there 2 years. I said, wow, that's pretty darn good. Well, they should last longer. Well, you should PM them. Do you change your oil periodically? Yeah. Well, you should change your labels periodically, your visuals periodically. So don't let them get out of date. Don't let them fall off. Don't let them get damaged by the environment or the operating conditions. Keep them up to date. Put them as part of your PM program. So as you go out to PM a pump or a motor, have the PM task check the direction rotation arrows, check the spare parts numbers, the parts labels on the equipment. We have another poll question as we come into the home stretch here. Talk about how much you could use visuals to enhance your safety, productivity, or reliability at your site. Many of you, looking at the attendee list, I know are using visuals, and some of you probably are just in your baby steps, and some probably haven't begun. So give us an idea of how much could an expanded use of visuals enhance what you're doing in safety, productivity, or reliability at your site. We've given you some examples. Some can help a lot, some moderately, marginally, or not at all. So give us some feedback here. And then as we wrap this up, we'll display the poll results. A number of plants that I've been working in with maintenance reliability, operations reliability, we've gone in, and the goal is not to apply visuals. The goal is to improve process reliability. The goal is to improve equipment performance and reliability. And to help accomplish that, a number of things need to happen. Proper preventive maintenance, predictive maintenance, proper operating procedures, proper maintenance procedures, standard maintenance job plans. And then you get to the point you ask yourself, where would a visual help? Visuals for lubrication, visuals for vibration analysis, visuals for predictive maintenance, visuals for proper operation, visuals for safety. So the purpose is to apply visuals. The purpose is to say what visuals would lead to improved performance. So you got your poll questions answered. We're getting ready to move along here.
Yeah, thank you. Thank you very much, Bob. While we're waiting for the poll results to tally up, thought I would just show your contact information as well as the book that I mentioned at the start of the webcast. Like I said, this is really the Bible on equipment visuals. And so if what Bob has been talking about in this presentation is of interest to you, you might want to pick up the book as well. And you can get that at the Brady website, which is shown here on the screen. We are going to take questions. We have a few minutes left. So if you'd like, go to the question and answer box on your screen and type in your questions there, and we'll take them in the order that they come in, or if there's some that look like they're more popular than others, we'll grab those and take a few questions. While we're waiting for you to type your questions in, let's just take a quick look at the poll results. Let's see, has that been pushed out to the audience?
Yes, it's live.
So in answer to the first question, it looks like about 40% of the people do have label printers, and about 45% of the people have both label printing and engraving machines. I think that's especially common in chemical oil and gas due to the outdoor nature of the work environment and especially harsh environments. And a lot of people do like the phenolic tags and the stamped nameplates just because of the durability there.
Yeah, the permanence of them.
Yeah. Let's take a look at the second question. How much could an expanded use of visuals enhance process safety, productivity, and reliability at your site? Oh, it looks like we...
there it goes. I hit the wrong button.
Okay. Yeah, so good 22% feel like there's a significant improvement that could be achieved, 51% moderate, and 22% marginal. So it looks like I think a lot of people got some value out of the presentation today and can see how the type of visuals that we're talking about can be of value to them. Let's jump over now, Bob, see if we've got any questions here.
Yeah, question. There's one question that says, how do visuals different from warning signs? My experience is that once people see a sign, they ignore it from there on out. And that's one thing you have to be sensitive to, because the visuals are very specific. So it's going to be on a piece of equipment about a specific point. And think about, doing lubrication, doing a PM. You're labeling lubrication points. You're numbering the points in a sequence. You have a lubrication diagram. So, it's designed to be a visual cue. Most of the equipment visuals are small. Most warning signs are large. Large signs tend to blot out things all around them. So, again, one of the things to keep in mind is the equipment visuals actually reinforce what's in an operating procedure, a maintenance procedure, reinforce what's in training. So what it takes is, we've got to reinforce that as part of our preventive maintenance and proper operation program. Another question. Okay, go ahead.
I'd say the one thing I would add there is a lot of times signs are used to provide information about an area. The benefit of using labels is that it's right there at the point of need, right there at the Zerk fitting or right there at the control. And so there's an application for both of those.
Yeah, and that's key. It's point of use labeling rather than general area labeling.
Another question here says, We've tried similar visuals, but sometimes they come off. This is also about durability, especially on outside equipment. What do you recommend to make sure they last?
Yeah. Well, I've had very good luck in clients I've worked with using the vinyl tapes that Brady has on their label makers. It's not a paper-based label. It's an outdoor vinyl label. They hold up very, very well. It's better than a bumper sticker material. Chris, did you want to say anything about that?
I will say that the outdoor durability of our labels depend on the climate. If you're down in the Gulf region, very harsh climate, or up in Alaska, probably you'll get about 5 to 7 years. In more temperate climates, a lot of times they'll last up to 10 years, 8 to 10 years. In terms of signage, we typically, in the harsher climates, we typically recommend aluminum or fiberglass. Those tend to last longer than the plastic signs that a lot of general manufacturing can get away with. And then with pipe markers, a lot of people do use the labels, and they do last quite a while, but if you switch to more of the wraparound or the snap-on type pipe markers, you often get some additional years of outdoor usage with those.
One of the things to keep in mind on label longevity is the surface preparation. And a lot of our equipment is outdoors, indoors, greasy, dusty, hot, steamy. So surface preparation is key to making these labels last. We can make the vinyl material and the printing on the vinyl material last a long time with UV protection and so on. But if that surface isn't cleaned right, quite often what we use are alcohol swabs, like you find in doctors' offices, alcohol swabs, some that leaves no residue to get that surface prep right. So that helps too.
Yeah, and we've got another question here. What material would you recommend against fading from the sun? So we've touched on that. But you can also put over laminates over the label to get even more outdoor durability. Sometimes a polyester laminate over the label will help to extend the life.
A clear laminate, yeah. And again, I've found that helps a lot on both indoor and outdoor environments. Make your label, but then put the clear laminate over it because it protects, gives it a smooth surface. It's an extra thickness, it's an extra layer of protection against things bumping it and scratching it too. So it makes them a lot more durable.
We've got a
question on, you showed the gauge indicator label. Have you seen anyone use a pointer label in combination with a range to show both the target and the acceptable range? And I'm going to jump back to the slide here. The question may have referred to this kind of a slide or this kind of a label. There's two types of gauge labels shown in the middle of this screen. One is the point, set point, and then a range. And the question was, it looks like it says, have I seen a combination of both of those? And the answer is yes. And you can custom print those on the Brady label machines with this Markware software down below. You can actually put marks in there for the set point and the range. In the green range, you can put a mark in there in the software. And the other part is on the transparent labels up above in the green, you can actually put a mark on there. Again, what I've seen done is provide the range, the green range, but then take a very fine point Sharpie, put a mark on there for the set point, and then put a clear label over it to protect that mark that's on there. Again, the visual labels, gauge labels especially, are designed to be very quickly to produce, very easy to produce, but also very informative. So that's a good question, the set point as well as the range.
Looks like we've got one last here. How can visuals reduce training and prevent errors?
Serves as that visual reminder. It's out there, and it's just like safety. You know, we've seen the pinch point. It reminds people of the pinch point, but those pinch point labels tend to end up overused in a lot of cases. So again, as you have your critical information on the equipment, make sure it's very purposeful, and it's a reminder of the key points in training. It's a reminder of the key points in a procedure, and it helps prevent errors. One of the things that has absolutely amazed me is I've spent 20 years studying NASCAR teams behind the scenes, and they use labels like you wouldn't believe. Labels in the shop, labels on the spare parts, labels on their race car as these visual cues and reminders. It's just, it's not because we're clueless, it's because we need that visual cue. We're human. How do they get a copy of this presentation?
Yeah, let me pull this up. This is the last slide here. You should be able to see my contact information. If you want to send me an email, I'll be happy to send you the slides. If you'd like to share the presentation, we're going to be, we've recorded that, and we're going to be putting a link up on the BradyID/Petrochem website. So this is our website where we provide a lot of both educational and product information that's tailored specifically to people in the heavy process industries. And so you can download white papers and other information there. And like I said, we'll also put a link to the webcast there. If you're interested in taking a look at any of the Brady printers or any of our other safety and process identification products, you'll be able to access that information as well. So just go to that www.bradyid.com/Petrochem website, and should have everything there that you'll need to get started with your process equipment.